So in continuity of limit of a function, we are linking limits to a function when the denominator, when you supply the value given as limits at the denominator, and the value gives you a 0. Like, for example, take this function f of x equals to 2x squared plus 3x, everything divided by x minus 2. And they tell you to find the limit when x tends to 2. So you notice that when you supply the value of x into this equation, it gives you 0 at the denominator. Like what I'm saying is 2 into bracket of 2 squared plus 3 into bracket of 2. So when you put 2 here, you have 2 minus 2. This equals to 0. So when you have this, you cannot get the limit. So what you do is what is called L'Hopital's rule. And it is done by you differentiating both the numerator and the denominator at the same time. So to differentiate both the numerator and the denominator, you differentiate one by one. So when you differentiate 2x squared, you get 4x. Then plus, when you differentiate 3x, you get 3. Then you differentiate the denominator. When you differentiate x, you have 1. And when you differentiate minus, which is a constant, you have 0. So we did it like this. So then you write your limit x tends to 2. So you input the value of x into this equation. So when you do that, 4 into bracket of 2 plus 3 all over 1. That's 4 times 2, 8 plus 3 all over 1. And the answer is 11 all over 1. Okay, so this is a question that is a bit more advanced than the previous one that we solved. If you check this, the previous question, when you put the limit at the denominator, you get 0. And you apply L'Hopital's rule, then you don't get 0 again. But now, for this question, we notice that when we start solving, if you put 0 here directly, you get 0. So L'Hopital's rule says that you differentiate this function. So applying that, when you differentiate this, when you differentiate x, you have 1 minus, when you differentiate sine x, you have cos x. So 1 minus cos x, then divided by, when you differentiate x squared, you have 2x. So you notice that when you limit this to 0, if you put 0 here, you still have 2 times 0 is 0 at the denominator again. So you have to apply L'Hopital's rule again, which says you should differentiate this whole function again. So when you differentiate this whole function again, when you differentiate 1, you have 0. And when you differentiate minus cos x, you have sine x. So for this, you have sine x all over 2. So now you can put 0 into this, so that you say sine 0 all over 2. And sine 0 is equals to 0 all over 2. And the final answer is 0.